Hello everyone, and welcome to the fifth part of this MOOC dedicated to hydrocracking. In the first two parts, the role of the hydrocracker was recalled and we spoke about the three characteristics. Then we described the first steps of the process consisting in heating up the feed. Let's now have a look at the chemical reactions involved. Once the hydrogen makeup gas plus recycle as well as the VGO feed have been heated up to 410 degrees C at 160 bars, we can now enter the pretreatment reactor to initiate the chemical reactions. As we said before, in this pretreatment reactor, every poison or impurity that may interfere with the cracking catalyst is removed. We will therefore remove metals, sulfur, asphaltenes, and nitrogen. Let's start by removing the metals. Indeed, these metals are irreversible poison of the cracking catalyst. So even if you have a few ppm of metals in the VGO, you must remove them as much as possible. It is recalled that the main metals encountered in the VGO are nickel and vanadium, and to a lesser extent sometimes a little iron and arsenic. To remove these metals, layers of hydrodemetallation catalyst, or HDM, are installed. Molecules where metals are present react with hydrogen, and the metals move and remain on the catalyst until the catalyst becomes saturated with metals. Nitrogen is also removed because it is a strong poison of the cracking catalyst, although it can be specified here that this is a reversible poisoning. The main reactions consisting in letting nitrogen molecules react with hydrogen create ammonia, just like in a conventional gasoline or diesel hydrotreatment. The amount of nitrogen that is targeted at the pretreatment outlet is between 10 to 20 ppm. This is what is called in English the nitrogen slip. This content is monitored very closely to ensure the proper functioning of the cracking catalyst. The presence of hydrogen and the operating conditions also lead to the removal of sulfur from the VGO. The reactions involved are very similar to those to remove nitrogen. Finally, we have other reactions that can take place, namely the hydrogenation of olefins when the feed contains some. There are also some hydrodearomatization reactions of certain polyaromatic molecules. All these reactions are exothermic, which is why we must control the temperature using a gaseous quench that is added to the reactor at several precise locations. Once the pretreatment reactions are over, the hydrocracking reactions can begin, most often in a second reactor. Unsurprisingly, the molecules will crack in the presence of hydrogen according to the following reactions. We can sort the reactions like this: paraffins cracking, hydrodealkylation, or the opening of the cycles, but also the hydroisomerization of hydrocarbons. Again, all these reactions are exothermic. But by the way, what are the catalyst types that we encounter in these two stages? See you in the sixth video of this MOOC to discuss this. In the meantime, do not hesitate to subscribe to my YouTube channel. See you very, very soon. Bye bye!